Hi, my name is Ava Martino and I'll be presenting on Lab 1 of Physics 2212, Charged Tapes. In the introduction, I'll outline the purpose of the lab and introduce some key concepts used during the experiment. Next, I'll address the initial conditions. I'll then analyze the tape's movement in computation models and then perform some calculations to answer lab questions. Finally, I'll address the discussion questions what if and why. The purpose of this lab is to prepare charged pieces of Scotch tape and observe its interactions with its surroundings. Then I'll determine how much excess charge is on one piece of charged Scotch tape. In this experiment, the system is the top tape while the surroundings consist of everything else. For a preview of the results, the magnitude of the electric force of the tape is negative 1.167 E negative 8. Some key concepts used during this experiment are Newton's second law, which is the acceleration of the object is directly proportional to the net force acting on the object and infinitely proportional to the mass. The formula for this concept is F equals ma. Another concept we use is Coulomb's law, which describes the force between two charged objects. The formula is F equals K times Q1 times Q2 all divided by the distance squared. Finally, gravitational force describes the attractive forces between any two objects with mass. The formula is F equals big G, big M times little m all divided by r squared. For the initial conditions of our lab and code, we found the tape length to be 20 centimeters or 0.2 meters, the mass, which was 2e negative 4 kilograms over meters, and the distance from the tapes was 0.025 meters. Now for some calculations. In order to determine the amount of excess electrons on the charged tape, we had to utilize the force of gravity formula, which is just mg. We found this to be negative 1.96 e negative 4. Next, we needed to find the charge of the tape, so we utilized the equation negative square root m times g times distance squared, all divided by k, which we found to be negative 7.379 e negative 8. Finally, we solved for the excess of electrons by dividing the charge of the tape by the charge of the electrons, and ended up with 4.6117 11 electrons in excess on the charged tape. For the next calculation, we found the surface area and the number of atoms. We utilized the length of the piece of tape, which was 0.2 meters, and the width, which was 0.0254 meters. We multiplied these together to get the surface area of 0.00508 meters. Finally, we divided the surface area by the area of the atom to find the number of atoms, which was 5.08 E, 17 atoms. For the first part of the script, we utilized Coulomb's law and the gravitational force formula in order to solve for the electric field and force of gravity on just a singular charged particle. However, in code 2, we are able to apply these to multiple charged particles on the tape, rather than just one particle. In the second code, the green arrows display the electric field directions for each of the charged particles on the tape, rather than just one. Now, to answer the what-if questions. If electrons were positive and protons were negative, what would change about the observations you made with your tapes and other charged particles, and other charged objects? The two pieces of tape will still repel each other because either way, one piece of tape will have a positive charge and the other a negative charge, so the results of this experiment would remain the same. Finally, to answer the why question. Compare the estimated value of the charge you get when you use your experimental data to produce a point charge model to the value you got with a line charge model. Why are they different? Which value is more likely to be closer to the real value, and why? The two codes differ because the first code oversimplifies by treating the tape as a singular charge, while the second code represents more charges on the tape. The second code is also more likely to be accurate because real tape has charges distributed across its surface, so the results are similar to what happens in reality.